Hello everybody, this is my intro for my package on the Unity Asset Store called HexTech. This is intended for making maps for turn-based hexagon wargames. The main action takes place in this map control object. You can drag and drop your map data objects, your textures that you use to create the maps. Your maps will get stored, your textures will get stored in the resources folder. For now, let's just start off by running this map that has already been created. It's already been processed the first time, so it appears rather quickly. The first time you run a map, it will be a little slow as the textures are generated and placed in your resources folder. As you can see, the map is zoomable, fully rotatable in all directions to any extent you want to allow the viewer to rotate it. Rivers, maps, I have 38 different terrain types right now based on 6 underlying terrains, starting from the ocean and working their way up. I'll analyze the structure of the terrain as we go along. So what's going on underneath the hood here? What's happening that's allowing all this to happen? I'll maximize this window a little bit more so we can see what's going on. Expand things in the scene view. What happens is you have different sectors for every 32 by 32 chunk of hexes. And in this case it's a 64 by 64 map, so you've got sector 0, sector 1, sector 2, and sector 3. So let's zoom in and analyze sector 1 and sector 0. What have we got here? Well, there's a hex frame that covers up the outside edge of the map. Basically, it's just a black shield. There's 2 different parts still visible on this one. If this was just a 32 by 32 map, then all 4 of those components would be visible, and it would cover the bottom, the top, the sides. But for each sector there is the main mesh that you can see, which is attached to this top object. The mesh filter and the mesh renderer here, this is what you're actually seeing. This is the terrain. But there's several other meshes that compose this sector. There's the mini map, which is a low-res version. It has 1 vertex per hex. It's just a tri-mesh. And it has basically the same UVs as the larger maps. There's a deep water map, which is a copy of the same mesh, just has a different shader attached to it. And then there's a transparent water layer that the land basically sticks up through. And where it doesn't stick up through, that's water. And where the land falls away a little further, then you can see the deep water underneath that. Then there is a move mesh, and this is the heart of the system. The move mesh, let me turn off the mini map. The move mesh is the same basic mesh. It has 1 vertex per hex. You can see each vertex is at the center of a hex. This allows you to raycast into this one collider and get the vertex that you are closest to and determine from that exactly where you are on the map. You can move from point to point on the move mesh, and your end points, at least, you may have to do a little interpolation along the way, but your end points at least are going to be on the graphic mesh. You can see here at the intersection of every move mesh vertex there is a graphic mesh vertex. So that's the country mode. Now it also does what is intended to do smaller versions of the map, smaller maps, smaller scale maps, intended for battle modes, where the elevation of the terrain plays a greater degree. In this case, the base terrain is just the height, and then there is a modifier over the top of that. In other words, you can have sand or snow or tree, forest or rough terrain. And all you have to do is drag a new map to that one map texture object, and here you see what I call the elevation mode. And as you can see, it's fully 3D. It has rocks scattered around, trees scattered around in the forests. It uses the same basic technology, has the deep water and the shallow water. There's also two modes of this map. There is a tiered map, which we just saw, where the center part of each hex is flattened out, and then there's the smooth mode, where the terrain slants smoothly from the center of each hex to the center of each adjacent hex. There's a little bit of random fractalization going on there on the terrain, but basically it just slopes down and up depending on what the neighbor is. And scroll down here and find the object. You can see we've got a sector 0. This is a 32 by 32 map, so there's only one sector. And you can see it has the same basic technology. It has the hex frame around it. It has the move mesh. It has the graphic mesh, the mini map object. Let's blow this apart a little bit here. And scroll back a little. As you can see, the mini map is just another mesh. It doesn't display in the main display because that camera is set to not display that layer. You have a mini map camera that actually has that layer. This means it's fully capable of doing the effects such as in Civilization or Enchanter, where you can zoom back from the main map and zoom into a mini map mode. As you zoom far back to the extreme, you could just fade back and forth between the graphic mesh that you can see here and the mini map, which is always underneath it and is the same size all the time. It wasn't really intended to be done that way, but now that I have done it that way, I realize that that's definitely something that can be easily implemented. As there's one vertex for each point in the move mesh, so it's very easy once you get, for example, if you raycast and you get vertex number 100, it's very easy to take and divide the number that you get by the width and get the module, divide the width by divide the number that you get by the width to get the x coordinate, and then get the modulus to get the y coordinate. Or is it the other way around? Anyway, it's all done in code for you. Basically, if you get because the vertexes are ordered that way, it makes it very easy to mathematically extract the x and the y coordinate from what you have. Now, how the map data is made. This is the map in Photoshop. This is what is read in. Each hexagon has a base color. There are 6 basic colors. There's deep water, there's shallow water, there's grass, there's hills, there's mountains, and there's really high mountains. So each hex has that associated with it at the very minimum. Some have more. There are add-ons, basically overlays or features, I call them, for each hex. There is an arid, there is a rocky, there is desert, there is grassland, there is ashen forest, ashen plain, tundra, snow, scrub, dense forest, and regular forest. There is ice, and at the very end there is lava. So how do these combinations come together to make the different terrains? I have put together a matrix of the different terrain types. Let me open that file. Terrain grid. So here you can see the different base terrains going up the left-hand side. Starting at the high mountains at the top, you got the ocean, sea, lowland, which is swamp, plains, hills, mountains, and high mountains. Then you've got the different terrains stretching out horizontally. You've got your basic terrain. You've got rocky, arid, desert, grass, ash, burnt forest, tundra, snow, scrub, forest, dense forest, jungles, ice, lava. And you can see how these different combinations add together to make the different terrains. So, for example, if you have a high mountain that has lava, then you can have the different different mountains. You have your mountains with snow, mountains without snow, and mountains that are totally covered with snow. If you have lava, you can have a lava with a mountain, and that's a volcano, or you can have lava plains. Your swamp, you have a marsh, and marsh with jungle is a swamp. So to make the distinction between something that's just a salt plain, you could also add new ones. You could have sea and ice, which would be like an ice pack, or oceans and ice, and that might be icebergs, or they could be something completely different. You could add a totally different terrain at any of these unused intersections here. You could have, I don't have icy hills, but you could have icy hills. You could add a whole new row and have a whole new section, mushroom forests or crystal lands or whatever. So anyway, and then the final detail that I need to talk about is how do you add the rivers and the roads. And I'm going to illustrate that just by drawing on top of this map a little bit here. And maybe this wasn't the best one. Maybe I want to pick one that actually has a different overlay on top so we can see. Let me zoom in on this forest right here. This forested hill next to this river. Alright, so the different points get read in for for the different data. This determines the underlying. This point determines the underlying terrain. This point determines what is overlaid on top of it. If the 2 points are the same, like they are over here, then that will just be the basic terrain, in this case, of plains. Back to this square. Then there are 3 more points that are read in for the rivers. This point, and this point. You only have to keep track of the rivers on 3 sides of a hex. I know it seems kind of counterintuitive, but the fact that it's between the hexes means that you don't have to keep track of it on both sides. Then there are 6 points read in for the roads. You can see the roads down at the bottom in the purple. These 6 points are read in, and these are per hex. The road will run from the center to the edge of the hex. If you want it to continue in the next hex, then you have to draw it on the other side too. This enables a road to run into a hex and stop, and not have to, just the fact that a road runs from the center of the hex to the northeast corner, for example, doesn't mean that it's going to run into the hex to the northeast. It'll stop at the corner unless this hex to the northeast also has a hex. So there's the basic functionality. I will probably do some more videos as requested in the future, but anyway, I hope this has been enough to help you get started and have fun.